The overall conviction among most specialists is that the hypothesis of how things came to be stays the essential explanation for the early seasons of the universe. This speculation joins the progress of stars, planets, etc., remembering life on those planets, counting ourselves. Not crossing, it's a really odd hypothesis named the Big Bang. It offers an illuminating evaluation concerning what could have occurred at first. The universe was thick in a short space, more certified than a pinhead with particles thick shocked. From this moment, a Goliath impact of matter and energy happened, known as the Big Bang. This event, happening billions of years prior, set up the spreading out of immense history. Anyway, levels of progress in authentic data have set off developing peculiarities with the suspicions of this hypothesis. When NASA launched the James Webb Space Telescope, the best and most advanced space science observatory ever, specialists speculated that its insights would confirm the hypothesis of the universe's beginnings. Unfortunately, following a year in space, the telescope flabbergasted specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's amazing limits have uncovered countless systems going as far back to a time so old that it challenges how we might interpret the universe's beginnings. This discovery has sparked an uncommon evaluation into what existed before the enormous detonation. One imperative moment in this mission occurred when cosmologist Rohan Natu, working with data from the telescope, suddenly found a cosmic system from just a short time frame after the Big Bang, making it the most far-off world at any point seen. NASA's revelation sent shock waves through laid-out specialists, highlighting the fantastic limits of the James Webb Telescope. Its fundamental target to change our perspective on the universe has just begun, promising to uncover astonishing experiences into the earliest times of the universe's existence. This period, hardly investigated previously, holds the key to understanding the development of the primary stars and systems. The telescope's revelations have conflicted with beginning hypotheses, uncovering systems with credits surpassing past assumptions. This unprecedented flood of early worlds has ignited a storm of logical inquiry, prompting specialists to accommodate these disclosures with existing theories. As researchers grapple with these revelations, they face urgent questions about the very nature of the universe and the powers that shaped its development. Past the James Webb Telescope's progressions, which are steady, it is found 1.5 million kilometers away from Earth, safeguarded from ordinary obstruction and cooled to almost absolute zero by its tennis court-sized sun shield. The telescope incorporates a huge, fragmented mirror and even sensitive instruments designed to uncover details of the early universe, already secret. This period, known as the Great Sunrise, occurred around 200 or 300 million years after the Big Bang, marking the second when the first stars and galaxies began to form structure. The process by which this unfurled remains a subject of great study, with hypotheses ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the colossal first light presents a surprising opportunity for cosmologists to test how they may interpret these complicated parts. By researching these ancient systems, researchers can either confirm the validity of their current models or uncover gaps in understanding that could lead to fundamental new discoveries. At first, the telescope was supposed to notice a couple of frail and small universes in its pilot studies. Anyway, reality has far surpassed these assumptions. The telescope's early images of the distant universe revealed a flood of systems with ages, sizes, and brightness levels that tested all estimates. This dazzling flood of early galaxies has set off a race among space specialists to establish new records for the earliest known systems, with new revelations arising routinely, leaving conventional experts in awe. Following the James Webb Telescope's revelations, specialists and onlookers have rushed to study the presence of these phenomenally advanced early universes. Some estimated that errors in the telescope's interpretation of major observations could be responsible for these unexpected disclosures. That said, the agreement remains that these disclosures represent a transformation in how we could interpret the early universe and offer an exciting look into the potential for infinite development. The new discoveries from the James Webb Space Telescope have raised central points of interest about the nature of the universe and tested the assumptions of standard cosmological models. While some researchers are investigating whether these insights can be reconciled with existing theories, others suggest that they might be the first signs that the universe is far more complicated and confusing than previously imagined. The real question at stake is our key understanding of how the universe we know emerged from early-stage chaos. The early revelations of the JWST could reshape our fundamental ideas of infinite history, uncovering insights not just on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFadden, senior researcher for science and exploration at the European Space Organization, puts it, "You build these machines not to confirm hypotheses, but to break them. You truly have no idea how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what could come after Hubble. Despite initial doubts, Weir and a small group began laying the foundation for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into the universe. This ability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its giant, cold star-like mirror, the JWST became the chief instrument for unlocking the mysteries of infinite dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation uncovered countless galaxies in what was believed to be a void patch of sky. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of probing much further into cosmic history. After 20 exhausting years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early efforts, such as the Early Release Science Program and the General Observer Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have challenged existing models of the early universe, revealing galaxies that defy conventional cosmological assumptions. These striking discoveries underscore the importance of pushing the boundaries of scientific inquiry and highlight the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As specialists continue to investigate JWST data, they may uncover further insights that challenge and expand how we understand the universe. When the first data began coming in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which often takes months, specialists decided to share their discoveries on preprint servers like AR14, a platform for research papers that haven't yet been peer-reviewed. This approach allowed for a new type of peer review to take place through social media platforms like Twitter, where independent experts could quickly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of discussion was both unprecedented and overwhelming. However, there were concerns about the possible downsides of this rapid spread of results. A JWST project researcher at STSCI warned that while the quick sharing of results facilitates rapid dissemination and discussion, there is also the risk of overwhelming the process. The general understanding among most analysts is that the hypothesis of how things came to be remains the vital explanation for the early seasons of the universe. This speculation includes the development of stars, planets, and life on those planets, counting ourselves. Notwithstanding its great name, the Big Bang offers a wide explanation for what could have occurred at the universe's beginnings. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive impact of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the unfolding of immense history. However, changes in scientific data have led to developing irregularities with the assumptions underlying this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever constructed, researchers speculated that its observations would support the hypothesis of the universe's beginnings. Unfortunately, after only 1 year in space, the telescope stunned researchers with its ability to peer deeply into the universe's past. The James Webb Space Telescope's extraordinary capabilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's beginnings. This discovery has sparked intense examination of what existed before the Big Bang. These revelations have ignited significant investigation into what existed before the Big Bang. While the discoveries from the James Webb Space Telescope continue to challenge our understanding, they are opening new paths for exploration and revelation. Many specialists now believe that the answers to some of the universe's most important questions might lie in these early observations, and that our current models may need to be updated or completely reconsidered. The presence of these distant ancient galaxies suggests that the universe might have evolved in ways that were previously unimaginable. It also raises profound questions about the very nature of time, space, and cosmic advancement. The implications of these discoveries extend far beyond the field of cosmology. They have the potential to reshape our understanding of physics, the laws governing the universe, and even the origins of life itself. As the James Webb Space Telescope continues to gather data, its discoveries could offer significant insights into the first moments of the universe, the development of the earliest galaxies, and the very processes that led to the rise of stars and other cosmic structures. These discoveries could ultimately help answer long-standing questions about the origins of the universe and the forces that shaped its development, providing a more comprehensive and accurate picture of our cosmic history. In the years to come, experts will continue to analyze the data returned by the JWST, refining their models of the early universe and testing new theories about the fundamental forces and particles that shaped its evolution. As the telescope reveals more about the universe's past, we will gain a deeper understanding of the present and the future of our universe. The James Webb Space Telescope has already proven to be a transformative tool, and its discoveries are likely to continue to astonish and inspire the scientific community for decades to come. Moreover, the data gathered from the JWST's observations might offer revolutionary insights into other fundamental questions, such as the role of dark matter and dark energy in shaping the universe. These mysterious components make up a significant portion of the universe, yet their nature and behavior remain elusive. By examining ancient galaxies and the intricate dynamics of their formation, the telescope could provide critical evidence to help unravel these cosmic mysteries. The telescope's ability to study exoplanets, planets outside our solar system, also holds great promise for understanding the potential for life beyond Earth.